We assume the ground beneath our feet is stable. We assume that the planet, a cooling ball of rock floating in space, is shedding its primordial heat evenly, like a dying ember. But that assumption is wrong. Deep inside, the Earth is lopsided. Recent data has revealed a massive thermal imbalance in our planet's interior. One hemisphere is acting like an open window, venting heat into the vacuum of space at a record pace. The other hemisphere is doing the exact opposite, trapping heat, insulating the core, and cooking the planet from the inside out. This isn't just a matter of a few degrees. This thermal war between the two halves of our world is driving the most violent geological events in history. It dictates where continents move, where supervolcanoes erupt, and why the Pacific Ocean is currently disappearing. For a long time, geologists treated Earth like a simple, layered onion. Crust, mantle, core, all uniform. But new simulations suggest we are living on two different planets stitched together. And if you want to understand why Africa is currently ripping itself in half, or why the Pacific Ring of Fire exists, you have to look at this uneven cooling. Because the Earth isn't just cooling down, it's breaking down, and it's doing it from one side first. To understand why this is happening, we have to look at the skin of the planet. For decades, we believed heat loss was uniform. But researchers at the University of Oslo recently shattered that idea. They ran a massive simulation, rewinding the clock 400 million years, to track the Earth's thermal budget. They reconstructed the movement of every continent and ocean basin to see where the heat was going. The results were stark. They found that the Pacific Hemisphere has cooled nearly 50 degrees Kelvin more than the African Hemisphere. Why the discrepancy? It comes down to a geological concept called insulation. The African side of the world is dominated by massive ancient continental crust. Think of this landmass like a thick wool blanket. Continental rock is old, silica-rich, and incredibly thick, sometimes extending 20 to 30 miles down. It also contains radioactive elements that generate their own heat. This combination traps thermal energy beneath it, preventing it from escaping into space. The Pacific side is the complete opposite. It is almost entirely oceanic crust. Oceanic crust is thin, only about 4 miles thick, dense, and geologically young. It sits beneath miles of freezing cold seawater. If Africa is a wool blanket, the Pacific floor is a wet t-shirt. It is an incredibly efficient radiator. This massive ocean basin effectively sucks heat out of the mantle and bleeds it into the water, where it eventually dissipates into the atmosphere. This creates a thermal gradient across the entire globe. You have a hot, insulated interior under Africa and Europe, and a cold, rapidly cooling interior under the Pacific. And in physics, when you have a massive temperature difference, you don't just get a breeze, you get a storm. This rapid cooling of the Pacific acts as a global engine. As the seabed cools, the rock contracts and becomes denser. Eventually, it becomes heavier than the liquid mantle beneath it. Gravity takes over, and the ocean floor begins to sink. This is the engine of subduction. The cold, heavy Pacific plate is literally falling into the Earth's interior, sliding under the lighter continental plates surrounding it. This is the mechanism that creates the Ring of Fire. Every volcano in Chile, Japan, and Alaska is a symptom of this heat loss. As that cold rock plunges down, it drags water and volatile materials with it, which lowers the melting point of the rock and fuels explosive volcanic eruptions. But the simulation showed something even more fascinating. These cold slabs of rock don't just melt and vanish. They sink all the way down. They fall for thousands of miles, traversing the entire depth of the mantle, like stones dropped in a deep pond, until they crash into the core mantle boundary. Over hundreds of millions of years, this graveyard of cold rock has piled up at the bottom of the mantle under the Pacific. And this accumulation of cold material creates a high-pressure environment that changes the behavior of the entire planet. It is actively squeezing the Earth's core from one side. When seismic waves from earthquakes travel through the Earth, they slow down significantly in two specific regions deep near the core. Scientists call these LLSVP large low shear velocity provinces, but casually they are known as the blobs. There are two of them. One sits under the Pacific and one sits under Africa. They are continent-sized mountains of distinct alien material, denser and hotter than the rest of the mantle. Here is where the uneven cooling changes everything. Under the Pacific, that constant rain of cold, sinking ocean floor is pummeling the Pacific blob. The cold slabs are crashing down on top of it, flattening it out, keeping it low slow and compressed. It's being stifled by the planet's rapid heat loss in that hemisphere. But under Africa, it's a different story, because the African continent above is a wool blanket. There is no cold ocean floor sinking down to squash the African blob. It is protected, insulated. As a result, the African blob is unstable and rising. It creates what is known as the African superplume. This massive upwelling of heat is pushing the entire continent of Africa upward. It's why southern and eastern Africa are so high above sea level compared to other continents, an anomaly called the African superswell. This isn't just elevating the land, it's breaking it. The rising heat acts like a blowtorch, thinning the crust from below. This is what is currently cutting the continent apart, creating the East African Rift Valley. The uneven cooling of the Earth is literally dissecting a continent, preparing to birth a new ocean right through the middle of Ethiopia. But the imbalance goes even deeper than the blobs. It reaches the very center of our world. The Earth's inner core is a solid ball of iron, growing slowly as the liquid outer core cools and crystallizes around it. But because the mantle is cooling unevenly, fast on the Pacific side, slow on the African side, the core is actually freezing at different rates. Seismic studies have revealed that the inner core is growing significantly faster on the side beneath Indonesia, the Banda Sea, than it is on the side beneath Brazil. The heart of our planet is lopsided. So why isn't the core shaped like an egg? Gravity. The gravitational forces at the center of the Earth are so immense that as the core tries to grow into an oblong shape, gravity essentially crushes the soft, hot iron back into a sphere. It is a constant, violent battle between thermodynamics trying to deform the core and gravity trying to perfect it. This churning flow of iron is crucial because it powers Earth's magnetic field. Without this lopsided growth driving the flow of liquid iron, our magnetic shield might weaken, exposing us to solar radiation. Our survival depends on this imbalance. There is one place, however, where the Earth's imbalance is visible to the naked eye, if you know how to look. In the Indian Ocean, just south of Sri Lanka, there is a massive anomaly known as the Indian Ocean Geoid Low. It is effectively a gravity hole. The gravitational pull in this region is so weak compared to the rest of the planet that the ocean surface actually dips. Ships in this area are floating in a depression about 100 meters, over 300 feet, lower than the global average sea level. For years, this was a mystery, but now it links back to the uneven cooling. Models suggest this gravity hole is caused by plumes of hot, low-density magma rising from the edges of the African blob. As the cold Pacific slabs sink, they displace hot material that surges upward under the Indian Ocean. This creates a region of low mass, deep underground, weakening gravity at the surface. It is a direct scar left by the thermal war happening 1,800 miles beneath the waves. But this raises the most terrifying question of all. What are the blobs? Why are there two distinct mountains of strange rock sitting on the core in the first place? The leading theory suggests that the Earth's lopsided nature isn't just about cooling, it's about a crime scene. 4.5 billion years ago, a Mars-sized planet named Theia smashed into the proto-Earth. The debris from that collision coalesced to form the moon, but simulations suggest that not all of Theia escaped. A large portion of that alien planet may have punched through Earth's crust and sunk intact into the mantle. The blobs might actually be the corpse of Theia. We are living on a chimera. Two planets fused together. The denser material from Theia sank to the bottom, forming these two massive piles. Now, billions of years later, the Earth's uneven cooling is interacting with these alien remains. The Pacific cooling mechanism is suppressing one half of the alien corpse, while the African insulation is allowing the other half to rise up and break the surface. So what is the end game? The uneven cooling is driving a cycle that will eventually destroy the Pacific Ocean entirely. The cold, sinking floor is pulling the Americas westward. Australia is drifting north. Eventually, the Pacific will close. A new supercontinent, often called Amasia, will form over the North Pole or the Pacific Basin. When that happens, the thermal blanket will shift. The heat trapped beneath the new supercontinent will build up and the cycle will reverse. The side that is cooling today will become the furnace of tomorrow. Our planet is a dynamic living engine driven by the desperate need to get rid of heat. We are just lucky enough to live on the cool, solid crust while the fire burns. beneath us. If you want to keep exploring the strange mechanisms that keep our planet alive, make sure you're subscribed. There are more mysteries buried deep underground that we are only just beginning to uncover. I'll see you in the next one.